further trig identities and their applications, knowing and being able to use the addition formula. So here we have the unit circle, we have an angle A, we have the points O, N and P. So by our knowledge from GCSE, we know that the length ON is the same as cos A, and the length NP is the same as sin A. So therefore we know that the coordinates of the point P are cos A sin A. Here's another point, the point Q. We can repeat the same process. We'll have angle B now, so we got cos B, MQ is sin B, and therefore the coordinates of Q are cos B sin B. This length, therefore, the length from Q to P, we can work out. We can draw a little right angled triangle. We know the points cos A sin A and cos B sin B, so we can work out the length of the sides. That side is cos A minus cos B, and this side is sin A minus sin B. As we can do that, we can use Pythagoras to say that the length from P to Q squared is cos A minus cos B squared plus sin A minus sin B squared. Once we can say that, we can times the brackets out. Then we can rearrange it. Cos squared plus sin squared A, cos squared B plus sin squared B, minus 2 cos A cos B plus sin A sin B. Well, we know that cos squared plus sin squared is 1, so that's just the same as 2 minus 2 cos A cos B sin A sin B. So that's the length PQ squared. However, we can also work out the length PQ in a different way. We could also work it out using the triangle OPQ. That triangle there, now shown in red. We could use for that as a non-right angle triangle, so we could use the cosine rule. A squared equals B squared plus C squared minus 2BC cos A. If we substitute the points in, then B and C are both 1, and the angle is B minus A. So it's 1 squared plus 1 squared minus 2 times 1 times the cos of B minus A. Rearrange it ever so slightly, 2 minus 2 cos B minus A. So now we've worked out PQ in two different ways. Well, we worked out PQ squared in two different ways. If we equate them, then, oh, I should have said first, that as we knew anyway, cos B minus A is the same as cos A minus B, because of the symmetry of the cos graph. If we equate them, then 2 minus 2 cos A cos B plus sin A sin B is equal to 2 minus 2 cos A minus B. Well, if we take 2 off both sides and then divide by minus 2, we end up with cos A cos B plus sin A sin B is equal to cos A minus B. That is a trig identity that we need to know. Cos A minus B is cos A cos B plus sin A sin B. And we could work it out the way that we've just shown in those previous few slides. Also, we could work out, if we want to do, that cos A plus B is cos A cos B minus sin A sin B. I'll let it to your own imagination to prove that is true. Also, we can work out sin A plus B and sin A minus B. All these are basically done in the same way, so you can work through those yourself. But those are 4 trig identities that we need to be aware of and be able to use. Cos A minus B is the same as cos A cos B plus sin A sin B. Cos A plus B is cos A cos B minus sin A sin B. Sin A plus B is sin A cos B plus cos A sin B. And sin A minus B is sin A cos B minus cos A sin B. So we can show things now. Let's say you want to show what tan A plus B is. Remember, when we do show that questions, we either pick one side or the other and try to show it's the same as the other side. Also, remember that tan theta is sine theta over cos theta. So tan A plus B is sine A plus B over cos A plus B. We can rewrite that using our trig identities, that tan A plus B, well, sine A plus B is sine A cos B plus cos A sine B, and cos A plus B is cos A cos B minus sine A sine B. So we can rewrite it using the trig identities. Now, if we divide both the top and the bottom by cos A cos B, then we end up with this rather exciting looking formula: sine A cos B over cos A cos B plus cos A sine B over cos A cos B, all over cos A cos B over cos A cos B minus sine A sine B over cos A cos B. But by doing that, lots of things cancel out. So we can do some cancelling. We can see that the cos B's cancel there, so we're left with sine A over cos A, but that's tan A. The cos A's cancel there, so we're left with sine B over cos B, well, that's tan B. Cos A cos B over cos A cos B in the denominator, that all cancels out, we leave with just 1. And sine A sine B over cos A cos B, well, sine A over cos A sine B over cos B, that's tan A tan B. So there we go. We've got tan A plus B is the same as tan A tan B over 1 minus tan A tan B. You may be asked to prove either of the tan identities using the sine and cos ones. So we also got tan A minus B. You should work through it yourself to make sure that you can prove that one as well, and then remember the proofs to be able to recreate them in an emergency, like an exam. So there they all are, the 6 identities. Let's use them. Show, using the formula for sine A minus B, that sine 15 is root 6 minus root 2 over 4. Well, sine 15 is the same as sine 40 minus 30. Why do we pick those numbers? We picked those numbers because by now we have learnt the third equivalence of them. So, using the addition formula, where A is 45 and B is 30, sine 45 minus 30 is sine 45 cos 30 minus cos 45 sine 30. Rewrite them as surds. Sine 45 root 2 over 2, cos 30 root 3 over 2, minus cos 45 root 2 over 2, sine 30, a half. Do a bit of a fraction sum. Root 6 over 4 minus root 2 over 4, and then group them up as you've got a common denominator. Root 6 minus root 2 all over 4. Like all such questions in exams, you have to show enough working out to show you haven't used a calculator. You can use the calculator. Using the calculator is perfectly okay, but you have to make sure the examiner knows, or at least thinks, you did it without using a calculator. Given that sine A is minus 3/5 and A is between 180 and 270, and cos B is minus 12/13 and B is obtuse, find the value of tan A plus B. Okay, a bit of a thought process. Obviously we need to know what A and B are. So tan A plus B is tan A plus tan B over 1 minus tan A tan B. That's one of our addition formulas. Sine is the opposite over the hypotenuse. So if sine A is minus 3/5, we can draw a right angle triangle. Again, ignore the minus signs, we'll worry about those in the future. You can use Pythagoras to find the missing side. So tan A is 3/4. If we think about the graph of tan, there it is, it's positive in the range 180 to 270, therefore tan A really is 3/4. And then we think about B, we do the same thing. B is adjacent over hypotenuse, so 12 over 13, again ignore the minus signs, use Pythagoras, the other side is 5. So tan B is 5/12, the opposite over the adjacent. When it's obtuse, then tan is negative, so tan B is therefore minus 5/12. So we use the shape of the graph in order to establish whether they're positive or negative. So tan A is 3/4, tan B is minus 5/12. So now we can use the addition formula, tan A plus tan B, substitute the values in, 3/4 minus plus minus 5/12, or 1 minus 3/4 times minus 5/12. Work it all out. It's a fraction sum. We should be able to do fraction sums without having to resort to a calculator. 16/63. You could obviously just type the whole thing into a calculator, but to get to and make sure you get the marks, you really do have to show the stages in your working out. Plus, it's fun. So, given that 2 sine x plus y is equal to 3 cos x minus y, express tan x in terms of tan y. Now we're getting into the exciting questions. So 2 sine x plus y equals 3 cos x minus y. Let's rewrite the sine and cos parts using the addition formula. So 2 sine x cos y plus cos x sine y equals 3 cos x cos y plus sine x sine y. That's using the formulas. Let's times it to brackets. 2 sine x cos y plus 2 cos x sine y is 3 cos x cos y plus 3 sine x sine y. So far so good. Let's now divide by cos x cos y. That looks like it's going to be a good idea. So now if we do that, lots of things will cancel. That's why it's a good idea. And apart from that, we want tan to crop up at some point, and since we know tan is sine over cos, if we want a tan to crop up somewhere, we're going to have to do something. So the cos y is cancelled there, so left with sine x over cos x. The cos x is cancelled there, so left with sine y over cos y. The cos x is cancelled there, so it's cos y over cos y. Oh, and they cancelled as well, and so we end up with 2 tan x plus 2 tan y on the left hand side, just 3 on the right hand side, plus, and then we've got sine x over cos x, sine y over sine y, 3 tan x tan y. What was the question again? Express tan x in terms of tan y. So we want again to get this to be tan x equals. So let's subtract the 3 tan x tan y and subtract the 2 tan y. We can now factorise the left hand side. Tan x 2 minus 3 tan y equals 3 minus 2 tan y, and then we can divide by 2 minus 3 tan y to end up with 3 minus 2 tan y over 2 minus 3 tan y. Fun, eh?